Hello students, today we are going to start a new chapter 15, that is probability. Probability. Probability means calculation of happening or not happening of an event that we consider probability. For example, probably it may rain today. When we say Indian cricket team has good chances of winning the World Cup. So in these statements, the word used probably or good chances comes in the preview of probability. So probability can be calculated under two approaches. So there are two approaches to calculate probability. First one is experimental approach. It is also known as empirical approach. Second is theoretical approach. So these are the two approaches under which we can calculate the probability. Experimental probability already you have done in class 9. So experimental probability is covered in class 9, and theoretical approach we will use in this class 10. Now first let me recall what we did in class 9 and what do we mean by experimental approach. So students, in experimental approach, the probability is based on experiments which are done and the results are noted, and on the basis of the results of the experiments conducted, we calculate the probability of happening or not happening of the same experiment or same event according to that. For example, suppose we have tossed a coin is tossed for 100 times. Now we know the possible outcomes of a coin are head and tail. Now suppose if our statistic says out of 100 times 60 times head appeared and 40 times tail, right? So now if we say without performing the experiment, before we perform the experiment we ask what are the chances if I toss the coin again it will be head. So in this case our answer of probability will be based on this experiment, and the formula will be used is number of trials in which the event happened over total number of trials. So according to that, probability of getting head will be number of trials in which the event had happened is 60. So it will be 60 over total number of trials, we know it is 100. So answer will be 0.6 if we write in decimal, or if we want to write in fraction, it will be 3 by 5 after reducing it to the lowest term. So this is what you did in class 9. In class 9, questions of probability were based on the results which are given in the form of statistics. Like here we have result of 100 times toss, and on the basis of that we used to calculate the probability which was based on the experiments, right? Now in theoretical approaches, we are not going to be based on experiments conducted earlier. In theoretical approach, what we will be doing, that is we are going to discuss. Now theoretical approach, it has been observed the experimental probability of an event approaches to its theoretical probability if the number of trials of experiments is very large. Like for example, here we have tossed the coin for 100 times, right? If we toss the coin for 1000 times or more than that, you know what will happen? Head and tail will have almost equal number of chances to occur. So this experimental probability will turn to theoretical probability in case the number of experiments is very large. This is one thing, right? Now in the theory of probability theoretical approach, what we do, we deals with the events which are the outcomes of an experiment. Obviously when we conduct an experiment, so experiment will result into outcomes. Those outcomes can be considered as events. For example, if we toss a coin, tossing a coin is experiment. Now when we toss, results head or tail. It may come head, it may come tail. Head and tail are outcomes known as events of the experiment, right? So there are two types of experiments. One is deterministic and second is random. Deterministic experiments are those experiments which when repeated under identical conditions produce the same results or outcome. For example, if your mother wants to make tea in kitchen, so she has to put the same ingredients in that water like tea leaves, sugar, milk, and result will be known, that is tea. So it is conducted under identical conditions. So when under identical conditions something we will conduct, so obviously same results are bound to come. And same happen in case of experiments in science or engineering. We obtain almost same results every time. So in an experiment when repeated under the identical condition do not produce the same outcome every time, but the outcome in the trial is one of the several possible outcomes, then it is known as random experiments. Like as I said earlier, in case of random experiment, the occurrence of outcomes is not pre-decided like deterministic experiments. For example, if we toss a coin, so it is not that if we toss a coin every time head will come or every time tail will come. So occurrence of events is not fixed. It may come head, it may come tail. So such experiments come in the preview of random experiments. So such experiments are known as random experiments. Now in this chapter you will be using few terminology. Out of that, one is elementary event. Now what is elementary event? An outcome of a random experiment is called elementary event. An outcome of a random experiment is called an elementary event. Like tossing a coin, head and tail are known as elementary event. And when we roll a dice, so the number 1, 2, 3, 4, 5 or 6, all these numbers 1 to 6 are called elementary events, right? Then there is one term which we will be using, that is compound event. Now what is compound event? For example, when we roll a dice, so outcomes are 1, 2, 3, 4, 5, 6. When we roll a dice, in case of dice, possible outcomes are 1, 2, 3, 4, 5 or 6, right? So writing all the elementary events in a curly bracket of an experiment is called sample space. What we call it? Sample space. Now what is the sample space of for tossing a coin? For a coin, sample space will be head, tail. So this is just example I am giving. Now we are discussing compound events. So after elementary events, we are discussing compound event. I will explain this with the help of example, you will understand easily. Now see, in case of a dice, 1, 2, 3, 4, 5, 6 can occur. So each of these 1 to 6 is known as elementary events separately, right? But in case I ask, if I roll a dice, what is the probability of getting an even? Now see, in 1, 2, 3, 4, 5, 6, 2, 4 and 6 are even. So if it comes to or 4 or 6, all are favorable. So this 2, 4, 6 becomes an event which is a group of elementary events that satisfies. So when group of elementary events satisfies, that is known as compound event. So an event is compound event if it is obtained by combining 2 or more elementary events of the same experiment. When 2 or more elementary events are combined, then it is known as compound. So as I use one more term here, favorable events. Now what are favorable events? Favorable events. An elementary event is said to be favorable to a compound event A if it satisfies the definition of compound event A. Once again, an elementary event is said to be favorable if it satisfies the definition of event A. Let me explain you with example. Here, suppose if I ask you here, what is the probability of getting an even number in case of a single throw of a dice, if we roll a dice? So we know if 2 comes, then also it is even. If 4 comes, then also it is even. If 6 comes, then also it is even. So out of all the 6 elementary events, there are 3 elementary events which satisfy this condition. So here we say favorable events, number of favorable events are 3. So number of favorable events will be known as 3. So these 3 elementary events satisfies the requirement that is an even. Here what is the condition? It must be even. And this condition satisfied by 3 elementary events. So favorable events are 3. Right? So next thing is negation of an event. Negation means when something we talk about happening, at the same time some part of it is there which indicates it may not happen. Like if we ask about anything, say if we ask, will it rain today, or there are some chances that today it will rain. So it means if there are some chance there will be rain, it means rest of the chances will indicate what? It may not rain. No? If I say in case of rolling a dice, 3 elementary events indicates towards even. It means there are some events which indicates that is not even. So in all the experiments, if there is a chance of happening of something, at the same time there is a chance of not happening of that thing also. Right? If we say there is a chance of occurrence of event A, if we say there is chance of occurrence of event A, right? Like in this question it is 3/5. So there is at the same time there is some chance of event not A, which can be denoted as A bar. A bar is negation of the event. If event A is there, so event not A is also there. So if you have the probability of happening of something, at the same time you must be having the probability of not happening of that thing. Right? Because already we have discussed in class 9, probability of an event, here E stands for event, always is 0 or greater than 0 and less than or equal to 1. The probability can be 0 to 1. It can never be negative. It can never be more than 1. So in case we calculate the probability in fraction, so in fraction numerator can never be bigger than the denominator. Right? So this is the main part in probability. Probability always lies from 0 to 1. When there is no chance of happening of an event, or we call it impossible event, its probability is 0. Like for example, suppose I have rolling a dice only, let we consider, it is a good example. So suppose if we roll a dice, so 1, 2, 3, 4, 5, 6 can come. Now if I ask you the question, what is the probability of getting 7 in a roll of dice? So what will be the answer? We know 7 can never occur in case of rolling a dice. So it is impossible event. It can never happen. So we say its probability is 0. So what is the probability? Probability of getting 7 is 0. Impossible event. It is called impossible events. Probability of impossible event is always 0. Now what if I ask you in the same way, if we roll a dice, what is the probability of getting a number less than or equal to 6? Now we know all these 1 2 3 4 5 6 numbers are either less or equal to 6. So in this case answer will be what? Answer of probability will be, probability of a number less than equal to 6 will be 1. It is known as sure event, means there is no doubt of not happening of this event. When we are confirm about the happening of a thing, we call it sure event. So here the probability will be 1. So except these two cases, now in all other cases the happening or not happening will not be certain, it will be uncertain. And when happening or not happening of an event is uncertain, that probability always will lie between 0 to 1. So rest all the probabilities will lie between 0 to 1, right? Now as I told already, we are discussing theoretical approach in class 10. In theoretical approach, once again let me clear you, while conducting experiment or discussing of the thing of happening or not happening of an event, one thing is clear, we will be knowing outcomes of the experiment, we will be knowing all the outcomes of the experiment, we will be knowing, but occurrence of the outcome will be uncertain, because we are going to discuss random experiments only, and in random experiments outcomes of an experiment will be known. We know if we throw a dice there will be 1 2 3 4 5 6, we know all outcomes, okay, what can come. But when we roll a dice, before rolling a dice, we do not know if we roll what will come on the face of the dice at the top. That is uncertain. Outcomes are known, but which particular outcome will come, that is unknown. So this is what we are going to discuss in theoretical approach, right? So the formula that you are going to use in case of theoretical approach is probability of an event will be equal to number of favorable outcomes over total number of possible outcomes of the experiment. So this is the formula that we are going to use in this class under chapter probability. So probability of an event, E stands for event, is equal to number of favorable outcomes over total number of possible outcomes, right? So this was the little knowledge about probability introduction, you can say. Now in this introduction I explained you the terminology, what is probability, what is elementary event, what do we mean by sample space, what is compound event, right, favorable events, that all we have discussed, right? Now one more important term is there in this chapter, that is equally likely outcomes. What is that? Equally likely outcomes. Now it is very important to understand this. In case of a coin, possible outcomes are head or tail. Probability of getting head is also 1 by 2, 1 favorable over total 2, and getting tail is also 1 by 2. So these are said to be equally likely. Same in case of dice. In case of dice number 1, 2, 3, 4, 5, 6, there are 6 elementary events in case of a single dice. The probability of each of these elementary events will be 1 by 6. What is the probability of getting 1? Favorable is 1 and total is 6. So 1 by 6. So probability is 1 by 6 in case of all these elementary events. So here each number occurrence will be same. Each of the event has same chances to occur. So these are known as experiments in which we have equally likely outcomes. Now let me give you one example in which we won't have the outcomes equally likely. For example, suppose if I have a bag contains 5 red balls and say 7 white balls. So total balls are 12, right? So here white balls are more than red balls. So red and white balls are not equal in number. So here probability of getting red ball, if I choose a red ball from bag without looking inside the bag, if I randomly pick the ball, so what is the probability of getting a red ball? Number of favorable outcomes 5 over total number of possible outcomes 12. And in case of white ball it will be 7 by 12. So here you see the probability won't be same. As white ball is more in number, so its probability will be bigger than as compared to probability of red ball.